number 213. Okay, so that's what we did in the last class. We did some proof kind of question in the last class. So here, one point I want to tell you today, that is, you have a circle. Okay, you have one circle and you have two equal chords. What is the meaning of equal chords? Those who remember, please tell me what is equal chord.
Equal chords are equidistant from the center.
Yes, equidistant from the center. Now, two equal chords are intersecting at a point P. Okay, if two equal chords are intersecting at a point P, then the distance of P, it's like PA will be equal to PD and PB
PC will be equal to PB.
PC. Yeah, PB will be equal to PC. So this is what you have to understand. This is applicable only for equal chords. Okay, so you can make a note of that. If two equal chords A, B and C, okay, I'll just write it down. You can probably draw this and say, if two equal chords AB and CD meet at point P inside the circle, then PA equal to PD and PB will be equal to PC. Okay, now let's do example 8. Example 8 here. Okay, what they are saying is two circles with centers A and B intersect each other at points P and Q. Okay, so you have got two circles like this. Okay, these two circles, where are they intersecting? At this point and this point. Let us mark that as P and Q. Now, this is the center of the first circle. This is the center of the second circle. What do we need to prove? Prove that the center line AB, center line AB means the line that joins the two centers. That line AB will bisect the chord PQ. What is chord PQ? This chord PQ, when you look at it, it's part of, we can consider PQ as a part of, as a chord of first circle and a chord of second circle, right? PQ is a chord of both the circle actually. That is why it is called common chord. Understood? Is that clear? PQ is a common chord. Why is it called common chord? Because you can consider, if you just look at the second circle, it's a chord in the second circle. If you look at only the first circle, it can be considered as a chord in the first circle. That's all. Is it clear or not?
Yes, ma'am.
So now what they are saying is this AB, this line AB will be perpendicular to PQ. That's what they are saying. If PQ is a common chord, then AB is going to be perpendicular to PQ. That is what you have to prove here. Okay. So we have to go ahead with the congruency and all that. Only then we will be able to prove it. Let's try to do that. For that, we have to do some bit of construction. So what is the construction that you have to do? Wait, before that, what is it that you have to prove? What is it that you have to prove? Can anyone tell me what is it that you have to prove? Are you there? Vidat, Martin?
Yes,
That
ma'am.
PQ is perpendicular to AB.
Yes, you need to say PQ is or AB is perpendicular to PQ. By the way, we need to also say that prove that the center line AB bisect bisects the common chord PQ perpendicularly. Okay, so two things are there. So bisect, so though when I draw it, it doesn't look like bisecting, but this point, bisect means equally dividing, right? So it has to be
So then PO will be equal to OQ.
PO and OQ should be equal. Yes. Okay, so that's what you should be. That's what it means. So let me write, what is it that you have to prove? AB is perpendicular to PQ, and which is our O? Let this be O. Okay, this joining point. Okay, that point where the perpendicular thing meets. So OP and OQ will be equal. This is what you have to prove. Okay. Now for that, we have to do some bit of construction. How will we do the construction? What is the construction that you have to do here? We have to form a triangle, right? So how will you form a triangle? You have to join AP. You have to join AP. You have to join AQ. Similarly, you have to join QB and you have to join PB. Okay. So this is the construction. Join AP, AQ, BQ, and BP. Okay. Any questions?
No, ma'am.
Nothing. Now we have to just look for the congruence. So which all triangle are we going to consider first? PAB, and you're going to consider PAB. Okay, first triangle is upper triangle, PAB, and then we'll consider the lower triangle. Okay, so what are the triangles? Consider triangle PAB and triangle QAB. Okay. Are they what are can you tell me what all ideas you know about PAB and QAB?
AB is common.
AB is common. Yes, AB is common. AB equal to AB. Fine. Then mhm.
Miss, since it is
Ma'am,
common, can we
AP
say
will be equal to AQ, the radii.
AP will be equal to AQ because they are radii of the first circle.
Miss, that means PAP and PP will also be same, right?
Yes, yes. This is radii of the first circle, and the other one will be BP will be, that's what you said, right, Martin?
Yeah.
P equal to BQ, that is again radii of the second circle. So this implies, what does it imply? Triangle PAB is congruent to triangle QAB. By what? SSS rule. Okay. Yeah. Now, what does that imply? From that, you can deduct few more. Okay. Have you? If you have not noted down, please note it down. Then I will proceed. Now, see, I'm just going to write this and this angle are same. Can I write like that? This angle and this angle are same based on our congruence. Is it acceptable or not?
Yes, ma'am.
So we need to write down that because we will need it for our next, we need to do one more congruence. So for that also we might need this. So what I will write here is angle, what was that? PAO is equal to angle QAO, right? How? CPCTC. Okay, so that we'll keep it. Now the next two triangles we have to consider. Which are they? We will consider the angle APO and angle AQO. Okay. So let's consider the next set of triangles. So consider triangle PAO and triangle P, not P, Q, QAO. Wait. Yes. So now triangle PAO and QAO is there. So angles both are same, right? So we have already proved about that angle PAO will be equal to angle QAO. So you can write here proved above. Where is it that we have proved? Here. Okay. So just write the reasoning as proved above. Then which is the common line here?
AO.
AO or OA. So OA equal to OA.
AP
Which
is
is
equal to AQ.
common. Yes. AP
That's a
equal to-
radii.
Yes. AP equal to AQ, which is radii. By the way, are we getting everything? So AP is one thing. This is SAS, no? So we can use SAS rule to show that they are congruent, right? Martin, are you with me?
Yeah, yes, miss. Yes.
Yes, ma'am.
Yes. So we will write triangle PAO is congruent to triangle QAO based on SAS rule. Okay, now what? So when PAO and QAO are equal, what all you are understanding? PAO and QAO are equal. PAO and QAO, okay. When PAO and QAO are equal, that implies that we already know AP and AQ are equal. OA is equal. What about OP and OQ? This side and this side, are we able to show they are equal?
Yes, ma'am. CPCTC.
By
Yes, ma'am.
CPCTC, we are able to show OP and OQ are equal. So first thing we have shown, I mean, not first thing, second thing, OP equal to OQ, that it is bisecting. That thing is done. So this implies that OP is equal to OQ. How? CPCTC. What next? Now we can also show that angle AOP and AOQ. Coming back, angle AOP and AOQ. This angle and this angle are going to be same, right? Again, CPCTC itself, you can say angle AOP and angle AOQ are going to be same. Let's write that also. Angle AOP is equal to angle AOQ. CPCTC you can write. Now what? Can we add these two? When we add angle AOP plus angle AOQ, what do you get?
180. Because PQ is a straight line.
180, since PQ is a straight line. Is a straight line. Now, so
Yes,
for
ma'am.
that, what should be that? Since they are equal, what would be the angle then? Since
Each is 90.
each has to be 90, right? Since angle AOP equal to angle AOQ, both has to be 90 degree. What does that mean? They are perpendicular, right? So we have proved. So angle AOP is equal to angle AOQ equal to 90 degree, hence proved. So both the things we have proved. So please write this down. So we can write AB bisects, AB bisects. If you want to write as a statement, AB bisects PQ perpendicularly.
Ma'am, could you scroll up a bit?
It's a lot actually. It starts from here. Okay, so you leave some space. Otherwise, we won't be able to do a lot of problems. So that's the reason. You leave this much space, maybe one page. Okay.
Okay.
And start from here probably. Yeah. Start from consider triangle PU and all that. Yeah. Yeah. So here, what you need to remember is, this is one, not as a theorem, but something which you should be remembering. When two circles, whether they are of, whether they are equal circles or not, the centers always bisect what? Bisect the common chord. This you should always remember. Okay, I have not written it down properly. Centers always bisect the common chord. This is very important. Two circles equal, or you can note it as a note. Two circles equal or unequal. Equal or unequal means what? They have the same radius or not. Equal or unequal, intersect each other the line joining their centers bisect the common chord. So these points are required when some of the proof questions come, and you need to know this. Joining their centers bisect the common chord. This is PQ is called the common chord because that is a code for both the circles. AB is considered as the center of the respective circles. Okay, let's do example 9. So here the question is, two circles with centers O and O dash intersect each other at points P and Q. So again, it's similar style. You have two circles and they have given centers also, and they are intersecting. So let me draw two circles first. Two circles with centers O and O dash. So this is O, this is O dash. They are intersecting each other at points P and Q. This is P, this is Q. The straight line APB is parallel to center line OO dash. So this is our OO dash. Okay, this is a straight line OO dash. And APB. Now APB is something I have to draw like this. APB. This is going to be APB. Now the straight line APB is parallel to central line OO dash. So this is parallel to this line. That's what they have given you. Prove that OO dash is equal to half of AB. What is AB? OO dash is half of AB. This you have to prove. But we don't know whether the circles are equal circles or what. We have no idea. Okay. So understood the question? You have two circles. The centers are marked as OO dash. They are connected using a straight line. And these two circles are intersecting. The intersecting points are P and Q. Okay. Now, the P is extended towards the left side and P is also extended towards the right hand side, so that you have A and B. B is on the second circle, A is on the first circle's circumference. Okay, and AB is parallel to OO dash. In that case, what you are asked to show is OO dash is half of AB. Fine. Now here, what we are going to do here is, first you are going to draw a perpendicular from O to AB, and similarly perpendicular from O dash to AB. Okay, so let's do that. So what is the construction that you're doing? Construction is, okay, here please write it as to prove is what you have to write. Okay, to prove. Don't write proof. To prove is O dash equal to half AB. What is the construction that you have to do? Draw draw OM perpendicular to AB and O dash N perpendicular to AB. Okay, so this is what you are asked to do first. So let's do the drawing part. Let me take blue color. So this is a perpendicular. This is again a perpendicular. Perpendicular means this is going to be 90 degree. This is going to be 90 degree. Remember that. This is also 90 because this is a perpendicular. This is also 90. Okay, so what would be that? Okay, mark it as this is M, this is N. So what is that shape? O dash NM or OMN O dash. What is that shape?
Rectangle.
It's a rectangle, right? Because I am drawing a perpendicular from O to M. So this is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree. So what you're going to get is a quadrilateral, which is a rectangle. Okay. So so we have a rectangle OMNO dash. Okay. Now, next thing is we will see what is, since opposite sides are equal. In a rectangle, we know opposite sides are equal. So what would be OO dash equal to MN, right? Opposite sides of rectangle OMNO dash. Are you understanding? Any difficulty? Yes, no?
No, ma'am.
Okay. So now, you have learned another thing. Whenever you are drawing a perpendicular from the center, what will happen to the chord? When you draw a perpendicular from the center of a circle, what did I say? Whenever you draw a perpendicular to a chord from the center of a circle, how does that chord is divided? How is the perpendicular dividing the chord? We have learned it in the last class.
Bisects.
So that this perpendicular bisects the chord AP. Okay, so that is another thing that you should be knowing. So what is it? AM equal to PM. Why? Because OM is a perpendicular. OM is a perpendicular to the chord AP, and OM bisects AP. Understood? So AM and PM will be equal because OM is a perpendicular to the chord. But again, OM is a perpendicular from the center. Okay, you can write that because O is a center. That's why I did not write explicitly perpendicular. Even if you don't write, it's okay. So OM is a perpendicular from the center to the chord. Martin, Nalin, are you guys understanding? So this is something which we have learned in the last class.
Yes.
Yeah. Okay. So OM is a perpendicular to the chord and it bisects AP. Similarly, we can write for O dash N also. Same thing. PN equal to, what is it? PN equal to NB. Same thing. O dash N is a perpendicular. Maybe here I'll write from the center to the chord PB, and hence O dash N bisects PB. Okay, so because of that, PN equal to NB. Now what? We can add, right? Are you?
Yes,
I
ma'am.
hope you're understanding all this. So
Yes, ma'am.
yeah, so O dash is MN. So let's write what will be O dash. We can just keep on adding and then we can get the result. What is MN? MN is PM is going to be half of AP, that we understood. Probably 1 minute. Probably you can write here as no, yeah, probably you can write it as half of AP here. This is half of what was it? Half of PB, right? Yeah, half of PB. That part also I want you guys to add there. Okay. Now we know OO dash equal to MN. Using that information, what is MN? What is MN? MN is MP plus PN, is it not? Or PM plus PN, right?
Yes.
So write PM plus PN as, if you want, I can scroll up and show you. I was just referring the textbook. See, OO dash is, this is OO dash, okay? And this is MN. So when I write MN, MN is nothing but, first I have to add PM plus PN. Only then I will get MN, okay? PM plus PN. So do that. PM plus PN. So what do you get? PM plus PN means what? Half of AP plus half of BP. Okay, half of AP plus, take half outside, AP plus BP. What is AP plus BP? Is it not AB? Just check again, AP plus BP, is it not AB? And then write hence proved. That's it. Okay, write this down. Tenth one. So here, out of the two unequal chords of a circle, the bigger chord is closer to the center of the circle. Prove it. That anyway we know, but they are expecting us to prove it. So the thing is, we have a circle, and whenever you have a longer chord, what they are saying is longer chord is always close to the center, and smaller chord is always far away from the center, right? I mean, that's common sense. We all know that, but they are expecting us to prove it. Okay, so out of the two unequal chords of a circle, the bigger chord is closer to the center of the circle. Prove it. That's the question. So let's try to prove it. I'm using the same thing, same drawing or same diagram used in the textbook. So we have two chord, like one is here, other one is here. So it's like on either side of the center. O is the center, AB is the first chord, and CD is the second chord. Okay. This OA is the radius, OC is again the radius. So write R there. Now draw a perpendicular from O to chord AB. Okay. Draw a perpendicular from the chord, from a center of the circle to chord AB. We know what will happen then. AB will be divided equally, bisected. Similarly, draw a perpendicular from O to the chord CD. Let that point be N. Again, this is also going to be 90 degree. So we need to write all these things. All of you are clear with what I did here? I just mark
Yes,
the
ma'am.
radius. Mark
Yes,
the
ma'am.
radius and draw a perpendicular from center to the chord. Why did I draw a perpendicular from the center to the chord? Because that shows that is bisecting that chord. Okay, that, you know, when I draw a perpendicular, that point where it touches the chord will bisect the thing. So let's do that. So what do you need to show here is, yeah. So draw, what is the construction part? You have to write all what you have done here. So what is the construction? Oh, wait, you don't need to do anything. You know why? Because sometimes they will give the drawing. When they give you the drawing, at that time, you might have to do the construction. But here you are constructing everything, okay? So even if you don't write the construction part, it's okay. You understood?
Yes.
So if they have given the drawing and you are adding more things to it, then you should say construction and write the extra things. Here, nothing they have given. You yourself is imagining and drawing things. So even if you don't write, it is okay. Okay, now let us consider first which triangle we need to consider. OAM. Consider triangle OAM. Okay. In triangle OAM, what all information you know? What all things do you know in the first triangle? First
AMO is a right angle triangle.
Yes, AMO is right angle triangle, but we are not looking for congruence here, okay? We don't want congruence. We are looking for the value. Why? Because you need to show that whichever is closer to the center, whichever chord is closer to the center, that is longer than the one which is far away. That is what you're proving here. Okay. I hope this is clear, right? So looks like CD is little far. So we have to show that CD is smaller than AB. That's the intention. So here, consider triangle OAM. Okay, we need to write one more point here. Consider the right triangle. Okay, right, because it's a right angle triangle. You can apply Pythagoras theorem only if it is a right angle triangle. So consider right angled triangle OAM. R square is equal to what? OA, no, why am I writing OA? I don't want OA. OM square plus what? AM square, right?
Yes, ma'am.
AM square. Or we need to find out AM. So what will be AM square? AM square will be R square minus OM square. That's it. Okay, consider that as equation 1. Now next triangle. Consider right triangle ONC or OCN, anything, whatever. Okay, I think I should consider ONC. In our ONC, what same thing. CN square is what I am interested in, because double 2 times CN will give me the length of the chord. Okay, so CN square is R square minus ON square. Fine. So this is equation 2.
Yes, ma'am.
Now, here, next thing is, okay, what is going to be AM? AM is half of AB, okay, and CN is half of CD, okay. Fine. Now we need some assumption. Now assume AB is greater than CD. Or instead of assuming, you can use a better word, that is, if you have used it in the beginning of the answer, if you have written draw, it's like here you can write draw chord AB such that AB is greater than chord CD. If we write it in the beginning like this, no, then that assuming step is not required in the in that part. So maybe you can, if you can include this line in between, that would have been nice. Can you include that line?
Yes, ma'am.
Okay. Done. Okay, so next is, see, the thing is, if you want to write everything like OM is perpendicular to AB, it would be really nice, okay? Otherwise, you have to draw this thing, it should be visibly drawn. Only then people will understand it is a perpendicular. Otherwise, you have to write everything in textual way. Like in textbook, they have written all what I said. Like AB is a chord, CD is a chord, AB is longer than CD, O is the center of the circle. Then draw OM in such a way that OM is perpendicular to AB. Draw ON to CD in such a way that ON is perpendicular to CD. Let R be the radius of the circle. So these things, whatever you see in the figure, no, you can write it as a text, right? Yeah, got it.
Yes, ma'am.
No, now so we have AM equal to half AB and CN equal to half CD. Since AB is greater than CD, can we say AM is greater than CN? Can we write like that? Because AB's half is AM, CD's half is CN. So if AB is 10 and CD is 5, okay, if this is 10 and this is 5, it's half. If you look at its half, AM has to be bigger than CN, right? Understanding? Did you understand or not? Confusing?
Yes, ma'am.
You understood or not? Eva, is it clear?
Yes, ma'am. Yes, ma'am.
Okay. So we have that thing. So since it's bigger, AB is bigger than CD, AB's half AM is definitely bigger than CD's half CN. That implies what? AM square is bigger than CN square. Okay. So now I'm going to bring in AM. What is AM's value? AM square is R square minus OM square, which is greater than, what is CN's value? R square minus OM square. Okay. Now R square and R square I can cancel out. Minus OM, that also I can cancel out. So what am I left with? OM square is greater than ON square, which can again show OM is greater than ON, hence proved.
Ma'am, done.
Wait. Did I go wrong here? I think I've gone wrong. I have gone wrong here, I believe. OM is, wait. OM is greater than is what I've said. Wait, the inequalities I have not considered here. Just a moment. Yeah, here I have written OM square is greater than ON square. I cannot write like that. 1 minute. So R square and R square cut off. Fine. Now, see, when it's not like this symbol is an inequality. Okay. So when it's called, I hope you understand, inequality means it's not equal to sign. So only if it is equal to sign, when it is moved to left hand side or right hand side, the things will remain. I mean, you have learned certain rules, right? See, R square, I can bring this R square, I'm bringing to the other side. It's fine. Now minus OM square greater than minus ON square. Okay, till this is correct. Now what are you left with? Minus OM square is greater than minus ON square. Okay, now I need to get rid of minus. See, when it was inequality, when it was equality, we had nothing to worry.
And
Equality
can't you
means,
make it ON square is greater than OM square?
that is, why are we doing it? Why are we
Because you're
writing?
taking ON to that side and OM to the other side.
Right. So you can think of exchanging the side, or in 10th grade, you will learn this, in inequality, what will happen when the side changes, or when when you multiply with a negative sign. Here, you are multiplying by -1. You're multiplying by -1, both the sides, right? So when you multiply both the side by a negative number, multiply or divide by a negative number, the sign will reverse. The inequality sign will reverse. So it will become like this. Okay, whenever you multiply by -1, inequality sign reverses. This you will learn in detail in your 10th grade. Okay, that is the reason why OM square is becoming less than ON square. What does that mean? OM is less than ON. Understood? Hence proved. Martin, any questions?
I'm
I
just doing it
corrected
myself.
Okay. Any of you have any question, please do ask. So this
No.
last part might be a little confusing because there is inequality coming in. Okay, inequality means it's not equal to sign. We are not writing OM square equal to ON square. That's not what we are writing. So when it is inequality and you are multiplying an inequality by a negative number, okay, it will reverse. That's the reason. Just tell me when you're done with writing.
Ma'am, could you scroll a bit up?
Mhm. This is the beginning.
No, a bit down. From
Bit down.
since A, B, there and C, D.
Yeah, this is fine.
A bit more down, ma'am. Yes, ma'am.
Done, ma'am.
Done. Okay. With that, try the next one, 11th one.
Okay.
Those who have completed, please try the next one. Okay.
Yes, ma'am. I can scroll all the way down.
Yeah. Done, all of you?
Yes, ma'am.
Yes, ma'am.
Let's try the next one. 10th question. Three boys, A, B, and C, are standing on the circumference of a circle with radius 10 centimeter. Okay, so let's draw a circle. Radius is 10 centimeter. So I'll write it like 10 centimeter is this.
Ma'am, it's the 11th example, right?
Oh, okay. Oh, yes. I'm sorry. It is 11th. 10th we just completed, right? So 11th. 11th one. Three boys, A, B, C, are standing on the circumference of a circle. So A, B, and C. With radius, okay. And the center at point O. This is O. If the distance between A and B equal to distance between B and C. So it means AB equal to BC, right? The distance between A and B is equal to, the distance between A and B is equal to distance between B and C equal to 12 centimeter. Find the distance between A and C. Okay, so we are considering it as a triangle. This is AC. Distance means we always do mark the distance like this, okay? So three boys ABC are standing on the circumference of a circle with radiuses. Center this. If the distance between A and B is this and distance between B and C is 12, find the distance between A and C. Okay. See, whenever you talk about distance, we never talk this distance. Which distance? This distance, okay? This is not what we talk about. So when even though it is like they are in the circumference of the circle, distance is always covered like this. This is how we always consider the distance. Okay, never go ahead with the roundabout way. So now we need to consider the distance between A and C. So how will we do this? Anything coming into your mind? Can we? Uh-huh.
It's a right angle triangle.
How, this is not a, at the moment we don't have a right angle triangle. So how can you make a right angle triangle?
Prove that
Okay,
we can
let's try to join these two guys, OA and OC. What is that? OA and OC. Don't you think it is going to be, this is 10, this is 10. Do you agree?
Yeah.
What OA and OC are radii, right? So since OA and OC are radii, you can mark it as 10. Now, what is the next thing? I'm going to draw a perpendicular from center O to AC. Okay. Can I do that? I'm going to draw a perpendicular. I'm just thinking, what can we do? But if I just find it out. But I don't know that distance also. Wait, what is the other option? So we have AB is 12, we know that. And BC is also 12, that also we know. But what would be, if I draw a perpendicular, will that help me? How can we do that? Yes, what I am going to do is, see here, two things we need to do. One is drawing a perpendicular from O to AB. AB is again a chord, right? Can we say AB as a chord? Can we see AB as a chord? Yes or no? A, just first I'll write and then only you guys should be writing. AB is a chord. Draw perpendicular OE, one second, OE to AB. Okay, so I'm going to draw a perpendicular OE. When I draw a perpendicular OE to AB, what will happen? What will be this angle? Is it not 90 degree?
It will also divide AB in half.
Yes, that is the reason I did that. So when I'm going to mark it as E. So, so what OE is there? Then AE equal to BE equal to 6 centimeter, right? Because it is dividing, it is by 6. So AE equal to BE equal to 6 centimeter. So we do now consider triangle. Which triangle? Consider triangle. If I consider triangle AOE, what will happen? Consider right triangle. Right triangle AOE. Because it is a right angle triangle. The angle E is 90 degree. So consider right angle triangle AOE. Here OE square equal to 10 square minus 6 square. If any of you disagreeing, please do tell me. OE square is equal to hypotenuse square minus the other side square. AE is 6, okay? Now this is 100 minus 36, which is 64. So what is OE? OE is 8. 8 centimeter. So we got OE as 8 centimeter. Okay.
Yeah.
Huh?
Okay, ma'am.
Yeah, now, so OE, we got the value. Now, what is the next thing that you have to do is, we need to find out the area of AOB. Okay, what is OB actually? OB, I'm again connecting O and B. When I connect O and B, okay, I'm getting a triangle. One second, we will see at the end what is AC and all that. Okay, now it's going to be a longer step. I don't think this will be asked for exam, because this is a long way. But in between, they might ask part of this question. That's all. Part of this question means some ideas you might have to understand, and then you can use those ideas to answer the question that comes for the exam. But this question as such, I don't think it will come. Okay, so here you have joined OB. Now consider that area of triangle AOB. Area of triangle AOB. So what I'll do is, this I am considering as step 1. This I am considering as step 2. Area of triangle AOB. How will you find the area of triangle AOB? Is it not half BH, which is half into what is B? 12 into what is height? Height is OE, which is 8. I hope you are all understanding. So 6 8s are 48 centimeter, square centimeter. Got it or not? Understood or not? This is AOB triangle. Look at the triangle AOB. In triangle AOB, how will you find the area? Area is half of AB. Half of BH. Base into height. Height is what we calculated. Height means what? Perpendicular distance, right? So, are you all with me? Hello?
Yes, ma'am.
Yeah, if you have a triangle like this part is called base, and this is called the height. This is the height. If you do, height is the perpendicular distance actually. So if you don't know the height, you won't be able to use half BH formula. Okay, so we have calculated as a first step, we calculated height, and then we are doing what? Finding the area. So this was our second step. Now, what is the next thing that we are doing here is, this is a pretty long problem. So here we are going ahead with this thing. What is it called? See, OA and OB are two radii, right? OA and OB are going to be same radii. It's same radii. It's not same radii. It's the radii of that circle. So both the side is going to be AO, and OB is also 10 only. So you can consider that triangle AOB and triangle, which one? Triangle BOC as congruent triangle. Can you consider those two triangles as congruent triangle? If
Yes,
you're,
ma'am. By SSS rule.
which all sides are equal? AO is equal
AO,
and
OC,
OC.
AB, BC, and OB.
AB and BC are equal. Yes, AB equal to BC, and then OB is common. OB equal to OB. Because of that, we can consider that those two triangles are this thing. When they are same, what is the advantage? What are we getting out of it? Angle OBA. I'll do one thing. I think I'll continue this in the next class, because it's like, I have another class immediately. So either you try doing this problem, or I will continue tomorrow. Tomorrow we have a class, no? So we will do it tomorrow. Got it? Yeah, because
Yeah.
otherwise it will take time. That's why. Yeah. Okay,
Okay,
then.
ma'am.
Bye.
Bye, ma'am.
Bye.
Thank you, Miss Barbara.
Thank
Thank
you.
you, ma'am.